Good morning. Today we have started the BSc second year, second step, first paper, that is statistical method 1, and we will start continuous uniform distribution. Continuous uniform distribution. Uniform, that is unique of all, that is uniform. That is the simplest continuous distribution. Continuous probability distribution is the uniform distribution, and it is observed in many situations. In general, when the frequency of various classes are observed to be more or less equal, that is, various class frequency are less or equal. That is, various class frequency is more, less or equal. In this situation, we will use the continuous uniform distribution. And the situation is the best for uniform distribution. It has a point important in the field of simulation. That is, in the field of simulation, most use the uniform distribution. In many places, uniform distribution is useful to develop further theory. The distribution function f of x of continuous random variable follows uniform distribution on the interval 0, 1 in respect of the distribution of x, and this is the property is useful in drawing model, sample or simulation. That is the drawing of sample and simulation we will use the uniform distribution. And uniform distribution class interval is class interval of the uniform distribution is 0 to 1, and when use the continuous uniform distribution, that is various class frequencies more, less or equal type, then we most useful the uniform distribution, and the class interval of uniform distribution is 0, 1, and which situation is which field use uniform distribution? Drawing of sampling first, and second simulation. In this field, use the uniform distribution. In which situation, that is variable, that is various class frequency is more, less or equal, and which field use uniform distribution? Drawing of sampling and simulation, and class interval of uniform distribution is 0 to 1. In this distribution, probability density function of random variable remains constant. That is, in the uniform distribution, probability density function is of random variable is constant. That is, PDF of the random variable is constant in uniform distribution. In this distribution, the probability density function of the random variable remains constant over the range space of the variable. Definition of continuous definition: a continuous type random variable x is set to follow uniform distribution. Continuous type random variable x is said to be follow uniform distribution over interval 0 to 1. A to B. A is the alpha and B is the, that is we consider beta. And if its probability density function is given by f of x, that is probability density function is f of x, and x is the random variable, that is a continuous type random variable. X is said to be follow uniform distribution over the interval a b. A is the alpha and b beta. If it is the probability density function is given by, that is f of x is the function of uniform distribution, that is equal to 1 by b minus a, that is beta minus alpha, and that is a is less than equal to x is less than equal to b, and that is a is less b, and otherwise 0. That is the definition of uniform distribution. That is a continuous type random variable x set to follow uniform distribution over interval a b, and if it is the probability density function is given by f of x equal to 1 by a b minus a, and if a is less than x and less than equal to b, that is a is less b, and otherwise 0. And we draw the graph that is x. X is the random variable, and the function of the uniform distribution is f of x, and we draw the function of 1 by b minus a. We draw the in this graph function 1 by b minus a, that is 1 divide beta minus alpha. That is we have considered here point a and here b, and that is this function 1 minus b minus a, and we join this function that is 1 by beta minus alpha, that is 1 by b minus a, and this distribution is also known as rectangular distribution. That is uniform distribution is also known as rectangular distribution. As the graph on the graph, probability density function describe a rectangular over x axis and between the ordinates at x equal to a and b equal to x equal to a, x equal to a, and f of and x equal to b. that is the x axis, and between the ordinals of x equal to a and x equal to b. And we have write the notation of this function, that is x has a uniform distribution with parameter a and b. This we read x has the uniform distribution with parameter a and b. That is the notation of uniform distribution. X has a uniform distribution with parameter a and b. And here a is the lowest value and b is the highest value of random variable. And if f of x greater than equal to 0 for all x belongs to R, and that is f of x is greater than equal to 0 for all x belongs to R, and minus infinity to infinity f of x dx equal to, that is limit a to b 1 by b minus a dx, and equal to b minus a divided b minus a equal to 1. Where we give the limit minus infinity to minus infinity f of x dx, that is integrate a to b 1 by b minus a equal to b minus a divided b minus a, that is equal to 1.